Hi everyone, Nevada Virtual Academy, one more proficiency problem, problem number 18. Use the diagram below to answer the question. A camera is placed 30 feet from a small tree. At this distance, the image of the tree in the camera is 24 millimeters tall. The height of the image is inversely proportional to the distance from the tree to the camera. How far from the tree should the camera be placed so that the height of the image is 6 millimeters tall? Okay, so what is this problem telling you is that basically the height of the image in the camera, right, is inversely proportional to the distance from the object that you are trying to photograph, right, to your camera. You guys remember inverse proportionality is telling you that the product of these two um, variables is always the same. So basically your height multiplied by the distance for this particular case for your camera is always going to be a constant k, right? Or you can write it in a different way and say that the height of the image in your camera is always equal to a number k divided by the distance. Okay, the product of height and distance is always the same, inverse proportionality. And you have, the first distance, 30 feet, and the first height, 24. That's, let's say, d1. This is height 1. So I know d1 times height 1 is equal to k, right? Height 1 times d1 equals k. And now I'm looking at the question. It says, how far from the tree? This how far from the tree, let me use a different color here, will be your second distance. Can the camera be placed so that the height of the image is 6 millimeters tall? And this is your second height. But what we said, for inverse proportionality, the product of your height and distance will always be the same. And for this camera here, always the product of distance to the height of the image, right, will be the same. And let's write the second proportionality statement, inverse proportionality statement, which is what? Height 2 multiplied by distance 2 is equal to the same number k. Now from these two statements you can write that height 1 multiplied by distance 1 should be the same with height 2, the second height of your image, multiplied by the second distance. What do we have to perform next? Well, plug in what you know. I know d1, I know h1. And because they're given to us in millimeters and feet, each one of them, so I'm not going to change them. I can leave my millimeters in millimeters and my feet in feet. It really doesn't matter. And I have what? Height 1, 24, multiplied by the first distance, 30, should equal second height, which is 6, multiplied by the second distance. To find the second distance here, I will not multiply 24 by 30 because I need to find d2. I'm just going to divide both sides by 6. 6 divided by 6 will be 1, my d2, right, my second distance. Here I can simplify because 6 goes in 24 4 times. And as you guys can see, second distance, d sub 2, should be 120 feet. And that's why d is the answer here. Obviously, this is just one way to solve it. Another way is, remembering that the image in the camera usually is, upside down, right? If I will have the image of this tree here, that will pretty much be like, like upside down. And that's basically your height, right? And then you have the distance here, and that's given to you 30. You can consider that distance right there. You can work with different triangles, but for this problem, I will stay here. I have inverse proportionality. The product of distance times height is the same. And obviously in my triangle here, that d is not the same thing with the distance from the camera to the object. It's something else, right? And like I said, we're gonna stick to the way I solved it, or if you have a different one, go ahead and use it. Thank you.